So we have started with the CAMS numericals in the previous video lecture. In this lecture, we'll continue with the construction of CAM profiles, of course, with again different inputs or different boundary conditions. So you can note down the next problem. I will dictate the problem as well as I'll write down the given data in the problem and what are we supposed to find out. The following data relate to a CAM profile in which the follower rises with uniform velocity and returns with UARM, that is uniform acceleration and retardation motion. That means while rising the type of motion is uniform velocity, and while returning it will be uniform acceleration and retardation motion. The data that they have given is, first one is minimum radius of CAM is 30 mm, so that is nothing but the base circle. So the base circle is given as 30 mm. The next data, maximum lift of the follower is given as 50 mm. Offset of the follower axis, it is given as 12 mm towards right. Angle of ascent or angle of rise, that is theta naught, is given as 80 degrees, followed by angle of 12, that is theta d, is given as 110 degrees, and angle of return or descent theta r is given as 60 degrees. Okay. So the rise stroke or the angle of rise stroke, which is also known as angle of ascent, denoted by theta naught, is given as 80 degrees, and this is moving with the uniform velocity. That is, the follower displacement is having a nature of uniform velocity, and while returning, the follower is having the nature of UARM, which stands for uniform acceleration and retardation motion. So in between the rise and return, there is a dwell stroke or dwell period of 110 degrees. So compared to the previous problem, how this problem is different is from this input parameter, that is, the follower axis is offset with 12 mm towards the right. This is offset with respect to the CAM axis. That means the follower axis and CAM axis are 12 mm apart, in which when they are saying towards right means the follower is towards the right side of the CAM axis. By what distance? By 12 mm. Okay. So we are going to see now two new concepts. One is how to draw the displacement diagram when we are having UARM, and how to draw the CAM profile when the follower is having an offset value. Okay. So these are the given data. We'll start with displacement diagram. So as it is, I have discussed in the previous lecture that irrespective of whatever is the problem data, few initial steps of drawing the displacement diagram will be same. That means I have to start by drawing a rectangle whose height, that is the height of the rectangle, will be equal to the maximum lift, that is 50 mm, and width of the rectangle will be equal to appropriate length of 360 degrees. That means you have to convert 360 degrees into some suitable length, that is either you can make it as 36 centimeters or 18 centimeters, or you can scale it down further also. And as suggested in the previous lecture, we require you to draw the displacement diagram in the landscape mode in your page so that it can have the better scaling and the error will be reduced here. Okay, so on one side of the page you draw complete displacement diagram, and on the fresh page you can start drawing the cam profile. So I'll start drawing the rectangle over here, whose height will be equal to 50 mm. So let me show you the dimensions over here. This dimension is 50 mm. Okay. And the width altogether I have taken it as equivalent to 360 degrees. That is, either you can take it as 36 centimeters or you can scale it further down to 18 centimeters. So once the rectangle is drawn, the next step again is common for all the problems. I will have to divide this rectangle into the rise stroke, followed by dwell stroke, followed by return stroke. Now if you see the total of this 80 plus 110 plus 60, it will not make 360 degrees, which means after rise, dwell and return there is some degrees of rotation left. That is nothing but your dwell stroke. Okay. So the first one is rise stroke of 80 degrees. So I'll just mark this 80 degrees over here. So I'll write theta naught equal to 80 degrees. So this is the first division. So if you have taken 36 centimeters, then this will be equal to 8 centimeters. And if you have taken this as 1:2, that is, if you have made this as 80 centimeters, then this will be equal to 4 centimeters. After rise stroke, there is a dwell stroke of 110 degrees. So this is theta d, which is equal to 110 degrees. Okay. At the end, we are having the return stroke of 60 degrees. Sorry, theta r equal to 60 degrees. Okay. So I hope this is clear. The rectangle consisting of width of 360 degrees, which we have divided into rise stroke, dwell stroke and return stroke of 80 degrees, 110 degrees and 60 degrees respectively. The remaining portion is of dwell nature. We are not bothered about this. We are not going to mention this because there is no displacement of the follower to be drawn over here. Okay. Now the rise stroke is with uniform velocity, return stroke is with URM. So let us see how to draw the displacement for these type of motions. Anyways, the next step, again common to all the problems, will be once you draw the rise stroke and return stroke in the displacement diagram, your next step would be to divide them into certain number of divisions, certain number of equal divisions. So if you are taking 6 divisions, just ensure that 6 divisions are there in rise stroke as well as 6 divisions are there in the return stroke. So you can choose even 8 divisions, but for that your scaling should be better. So you cannot draw a very small diagram and make 8 divisions in that, so the drawing will become too shabby and it again lead to confusion. So I suggest you to go for 6 divisions. So let me mark those 6 divisions over here. Similarly, 6 divisions in the return stroke also. Okay. In the next step, I will ensure that once the division is made, I will give the numbering. I will start with 0. So this is the first division line, so it will be 1, 2, 3, 4, 5 and 6. Continue the numbering, so this will be 7, 8, 9, 10, 11, 12 and 13. Okay. So till here, all the steps will be common for all the problems. Now in the next step, we need to draw the displacement curve here for the right stroke and displacement curve here for the return stroke, depending upon what type of motion it is having. So for right stroke, it is having uniform velocity. So we have discussed in the previous class, for uniform velocity, all you have to do is just draw a straight line from start to the end point. So in this case, this becomes our starting point, this becomes our ending point. So I'll have to just draw a straight line in this fashion, start to end. Okay, this is the curve of the follower displacement with uniform velocity, that is during the right stroke. So once it reaches here, it is followed by a dwell period. So in dwell period, we know that the radius is not changing of the cam profile, and also the follower displacement will be 0. That means it will neither rise nor it will return or fall back. It will be horizontal. So the displacement of the follower in the dwell portion will always be horizontal. Okay. I hope it is clear till this step. Next we will have to switch to the return stroke. The return stroke is with uniform acceleration and retardation motion. So just observe the procedure of how to draw the UARM profile. So for return stroke, which is the start point over here, so we have stopped here, that means this becomes our start and this point becomes our end point. Okay. Whereas for right stroke, this was our starting point and this was our ending point. For return stroke, this will be start and this will be end. Okay, I hope this is clear. The procedure is very simple for UARM. Out of these divisions which you have made, you will have to locate the line which is exactly at the center, that is, in this case, line number 10 is the center line for this entire stroke. So I will be focusing on this line number 10. You will have to divide this line number 10 into 6 parts vertically. Okay, why 6 parts? Because we have taken 6 parts in the right stroke as well as 6 parts in the return stroke. That's why I am using that 6 divisions everywhere. So I have located the middle line, that is line number 10, and this line I am going to divide into 6 parts vertically. So let me show the marking over here. Okay. So I hope it is visible. These are the 6 divisions that I have made vertically division 1, 2, 3, 4, 5 and 6. Okay. So once this is done with the thin lines, you will have to start with this starting point and connect the first two dots or the first 2 points in this fashion. This is first, this is second. Okay. I'll repeat the same procedure from the end point now. From the end point again I will join these 2 dots in this fashion. Okay. From the start point you join to the first 2 dots, and from the end point you join the last 2 dots. So once this is done, I will mark the intersection points. This is the first line, and wherever it intersects the first line, I'll highlight this. The second line intersecting with the second line over here. This is the third line, so I'll be just highlighting the center point over here. Fourth line intersecting the fourth line over here, and fifth line intersecting again the fifth line over here, and sixth would be again at the end point. So I'll repeat. Line number 1 at the top what you have drawn, that line intersecting with the first line of that stroke, that will be your intersection 1. Then like a second slope line intersecting the second line of the stroke will be your second point. Third point would be obviously the midpoint. Fourth point would be the fourth slope line along with the fourth line of the stroke, and fifth slope line intersecting with the fifth division of that stroke will give you the fifth intersection point, and at the end it will be sixth intersection point. Okay. In the rise stroke also we can highlight the intersection point. Line number 1 is intersecting over here, line number 2 over here, line 3, line 4, line 5 and 6. Now I am going to join all these intersection points by a smooth curve from start, passing through all these points. Okay. So this is the line. So I'll just once again try to darken this displacement curve. Here it is a straight line. Once again a straight line till here, followed by a smooth curve. Okay. So once this is done, we'll have to label them. So for starting with line number 1, I'll start numbering them with P1, P2, P3 and so on. This will be P6, this is P7, this is P8, P9, P10, P11, P12 and P13. I have named all the intersection points starting from P1 to P13. Okay. So this will complete your work of displacement diagram. Now let us move to the drawing of CAM profile. So the first step to draw in the CAM profile would be to draw the base circle. So this is a base circle radius that they have given, which is as 30 mm. Base circle radius is 30 mm. So I'll have to draw a circle of a radius 30 mm. Okay, no need to draw the axis line, just for your understanding I have drawn it. I have drawn a base circle. Let me name it. This is base circle of diameter 60 mm, because the radius is 30 mm. So I have written base circle with the diameter of 60 mm, and this line will represent the axis of the CAM, which is exactly at the center of the circle. Now in the previous lecture, in the previous video lecture, what we had done is we had drawn the follower exactly at this particular point, right? Why we had drawn the follower exactly at this particular point is that because that was an inline type of CAM profile. Inline means the follower axis and CAM axis will be along the same line. But in this case, they are telling that the follower axis is having an offset value of 12 mm towards right. That means towards the right side of this axis, 12 mm apart, you should draw the axis of the follower. So I will draw one more axis line over here. Okay, which is 12 mm apart from here. So let me show it over here. Okay, this is 12 mm. Okay. Now the follower has to be drawn exactly over here. Okay. So the initial position of the follower will be here, which is 12 mm towards the right side. This is the offset distance. Okay. The next step, from the center of the base circle, I will be drawing one more circle whose radius will be equal to 12 mm. That means if I draw a circle, it should be tangent to the follower axis. This is a very important step. So you will have to draw a circle whose radius will be 12 mm. You have to draw the circle exactly at the center of the base circle. So when you draw this circle, you can see that the polar axis will be tangent to this circle, because radius is 12 mm, this offset is also 12 mm, it will be exactly tangent to this circle. Now, so I hope you are getting the picture of what is the difference between the inline axis and the offset axis. So these are the initial work that we need to do for the offset axis. Once this is done, the next step would be to again indicate the rise stroke, dwell stroke and return stroke in the displacement diagram. Again, listen very carefully. In the previous or the regular cam profile construction, I have measured the angles from this reference line, that is the axis of the cam. From here I have started measuring the angles of the rise stroke and dwell stroke and return stroke. But in this case there will be slight change. You will have to draw a line starting from the follower tip to the center of the cam. Okay. Starting from the tip of the follower to the center of the cam, you have to draw the line, and this line becomes your reference line to measure all these angles now, rise stroke, dwell and return. So starting from this line, I will first draw the rise stroke, which is of 80 degrees. Okay. So I will show the angle over here. This complete angle is your rise stroke, that is 80 degrees from here to here. Then you are having a dwell stroke of 110 degrees. Okay, somewhere over here. So this angle is 110 degrees. And finally you have again a return stroke of 60 degrees. So this is your return stroke of 60 degrees. Okay. The change here is I have changed the reference line. Reference line now starts from the tip of the follower to the center of the cam or the center of the base circle, and from that line I have measured 80 degrees, 110 degrees and 60 degrees respectively to mark the rise stroke, dwell stroke and return stroke. The next step again would be what we have done here in the displacement diagram. Once I had drawn the rise stroke and return stroke, what we have done is we have divided them into 6 parts. I will repeat the same procedure over here. Divide them into 6 parts. Okay. Similarly, return stroke I will divide into 6 parts. And whatever numbering we have done here, I am going to give the same numbering starting with 0. So this will be 1, 2, 3, 4, 5 and 6. This is 7, 8, 9, 10, 11, 12 and then 13. Okay, I hope it is clear. Now in the next step, we need to draw the lines from these divisions, but there is a slight twist as compared to the previous problem. In the previous problem, we have drawn the radial lines from these divisions to the center of the base circle, but in this case it will be slightly different. Just observe the 0 point, right? This is point 1, 0 point, it is having a line which is tangent to this small circle. So with this logic, I have to draw the lines from 1, 2, 3, 4, 5, 6 tangent to this small circle. I'll repeat. Point number 0, that is wherever this tip of follower is there, this from here, there is a line that is nothing but the axis of the follower which is on the tangent to this small circle. Since the 0 line is having tangent line to the small circle, I'll ensure that line 1, 2, 3, 4, 5, 6 will also be tangent to the small circle. Similarly with 7, 8, 9, 10, 11, 12. Okay. So it will be something like this. From 1, I'll draw a line which is tangent to the circle. From 2, I'll draw a line which is tangent to the circle. From 3, a tangent to the circle. From 4, once again tangent to the circle. From 5 and from 6. So all these lines you can extend it outside. Okay. So let me rub this. Now look how I am going to draw the tangent from point 8 onwards. From point 8, do not draw the tangent line towards the right side. It has to be to the left side only. So I'll start with 7. From 7, I have drawn a tangent line. From 8, from 9, 10, 11, 12 and 13. So I'll extend these tangent lines. Okay. So these are the only changes with respect to the offset and inline. Do not draw the radial lines to the center of the base circle. Draw the radial lines to the tangent of this smaller circle that you have drawn, both for the right stroke as well as for the return stroke. So once these lines are drawn, the next procedure will be same as what we have done in the previous problem. That is, I will need to mark these P1 to P13 from, I need to transfer them from displacement diagram to the CAM profile. So I am going to do that. So to locate P1, I will set the compass from point 1 to P1. That means I will set this distance from point 1 to P1, and the same distance have to be cut over here. Okay. So if I cut this, this intersection is P1. Similarly for P2, I need to set the compass from point 2 to P2, and with this distance I need to cut an arc over here. So this will be P2. Similarly for third one, P3. For fourth one, P4. For fifth one, P5, and for sixth, P6. I'll repeat the same thing for P7, P8, P9, P10, P11, P12 and P13. Okay. So once you get all these position points from displacement diagram to CAM profile, all you have to do is, starting with point 0, join all the intersection points or join all the P points with a smooth curve. So let me darken this. The orange line, whatever I have drawn over in the CAM profile, is the final construction of CAM profile. Okay. So this is the base circle. So this will be the CAM profile. This is the knife edge follower. Okay. From the exam point of view, if you look at these extended lines, whatever I have drawn, or if you look at the smaller circle, or if you look at the divisions what we have made, all these things are only for our construction purpose or our reference purpose, because finally what I want is this particular orange colored profile line, that is the CAM profile. This is what we are looking for. To get this, whatever you draw, okay, to obtain the final CAM profile, whatever you need to draw or whatever you need to construct additional, ensure that you draw them with very thin lines and darken only the final CAM profile. The same thing will apply here also. So all these division lines what we have made, these are only for our reference purpose or for our construction purpose. Only the final orange color line what I have drawn over here, that should be dark and clearly visible. Here, if I draw them very lightly, it won't be visible to you. That's why I have drawn all the lines a little bit dark. So it might not look so clean. But in your books, if you draw them light and only make the final profile dark, then this will look very clean and neat. Okay. So this will complete the second problem on CAM profile, wherein we have introduced a new type of displacement, that is UARM, and we have introduced a new type of follower axis, that is the offset axis. Okay. Now one question should arise in your mind, that in the entire problem statement that I have dictated or I have written over here, nowhere it is mentioned what type of follower you are supposed to use. That means whether you are supposed to use a knife edge follower or a roller follower or a flat follower, it is not mentioned anywhere. But still I have drawn or solved this problem by using knife edge, because if at all they want you to draw the CAM profile using a roller follower, then they would have mentioned what is the roller diameter over here. Okay. If roller diameter is not given, then it is to be understood that this has to be solved using the knife edge profile. And if they specifically mention the roller diameter as 10 mm, in that case we will have to draw the follower as roller type of follower. So in the next problem, we will be taking the roller type of follower here. Okay. So I'll be making again two changes in the next problem. One is I'll change the follower type from knife edge to roller. That is one thing. Second is, instead of uniform velocity, we'll now introduce cycloidal type of displacement of the follower. So if the cycloidal follower displacement is given, then what changes will be incorporated in this displacement diagram, that we'll be seeing in the next class.
Yes, good morning everyone. In the last two classes, we have derived Darcy equation, we have derived Chase's formula, then we solved few examples.